Now there's this thing called the intermediate value theorem. Now, what this says is that if we had some function, let's say it looked like this, doesn't matter. If we know that there's a point here, so that dot, let's say this is x equals 2, and up here is x equals 7. So if we know that this function is continuous, let's write that, f of x must be continuous. Enjoy my terrible handwriting. F of x must be continuous, and if it is, then that means between 2 and 7. So if x is between 2 and 7, then there has to be, or if instead of x, let's say, let's generalize it to c. If you have some number c that's in between 2 and 7, it could be 2.5, it could be 6, could be anything, then, and let's say this value at x equals 2 is 3, and at 7, it's 5. So if c is between 2 and 7, then there has to be some c, must be some c where f of c, or where c three f of c greater than or equal to 5. So what this means is that if we have some value in here, could be any point on this line, then there has to be some value on this line that equals every single number in between 3 and 5. So this number is probably around 4. Then this is probably something like 4. This value has to exist. Doesn't matter what the function looks like. Like let's say instead we had this crazy function like this, then it doesn't matter. As long as it's continuous, there is some value at x equals, let's say x is, or c is 4, so probably around here. There has to be some value where f of c is equal to every single number in between here and here. So it has to be a 4, a 2.5, everything. And these can all be contained in these little loops or whatever. So the way you justify that is just say there must be some c where f of c is between those two values, and that'll get you the point. But remember that it has to, f of x, or whatever this function is, has to be continuous for this theorem to apply, because we could have just a big discontinuity, like if we had, instead of that where it was discontinuous, if we had this, then that, then there's no value, or whatever this value is, let's say it's slightly less than 5, then there's no value there if it's discontinuous. There doesn't have to be a value. There could be, but it does not have to be, which is what we're trying to prove with the intermediate value theorem. IVT. I think you can write it as IVT just to make it simpler.